Welcome back to Let's Do It and Learn, the Linux way. In our last video, we successfully installed our Ubuntu virtual machine on Oracle VirtualBox. If you missed that or got stuck along the way, kindly check out episode 1 right here. Today, we take real control. In production environments, enterprise engineers never work directly inside a laggy hypervisor console. We connect remotely. Today, we are going to SSH into our virtual machine just like we do in real enterprise data centers. Let's power on the machine and jump straight in. First, we need to find out the IP address of our virtual machine. Let's log in using our credentials. To check our IP, let's type the classic command, ifconfig, and look at that. We hit our first error. Command ifconfig not found, but can be installed with sudo apt install nettools. Don't panic. Modern Linux distributions minimize the default utilities out of the box to keep the operating system lightweight. The classic ifconfig command now lives inside a package called nettools. Let's install it by running sudo apt install net-tools. That it's installed, let's try running ifconfig again. Perfect. Now, we can see our network interface details right here on the screen. Take note of this IP address. Notice how it starts with 10. Keep that in mind. It's time to check our SSH connection. Let's switch over to our native Windows command prompt and try to connect remotely. Type SSH username at your IP. Oh no, the terminal is completely frozen, and there it is. Connection timed out. Why did this fail? By default, VirtualBox puts your server on a NAT network. Think of NAT as a one-way security wall. Your virtual server can look out at the internet to download packages, but your Windows laptop cannot look inside to talk to the server. To fix this, we need to bridge the connection so the server sits right next to our laptop on our local home router. Let's fix this network layout. First, we will safely shut down our VM. Head over to the VirtualBox settings and select the Network tab. Here, you can see it says Attached to NAT. Let's change that drop-down to Bridged Adapter and click OK. Let's power our VM back on, log in, and run ifconfig one more time. Look at that! Our new IP address starts with 192. This confirms that our bridge network configuration worked perfectly, and our server is now directly on our home network. Let's try to SSH from Windows again, using our brand new IP SSH username at your IP. Wow! This time, we got a completely different error. SSH connect to host port 22. Connection refused. Believe it or not, this is excellent progress. A timeout means the network path is completely dead. A refusal means the network is wide open, but the server just slammed the door in our face. Why? Because a fresh Ubuntu server doesn't actually have the SSH software package running by default. Let's check on the service back inside VirtualBox. Sudo systemctl status SSH. The system tells us ssy.service not found. Let's install it using our package manager. Sudo apt update and sudo apt install opens-server-y. Perfect! As you can see on my screen, the installation went through flawlessly. But wait, bro, let me drop a very important troubleshooting note right here. Depending on your local home router, some of you might get hit with a failed to fetch error or a connection timeout right when you run that command. Don't panic if that happens to you, because we just flipped our network interface from NAT to Bridged while the virtual machine was still running. Ubuntu's background routing tables can sometimes get confused, causing the server to temporarily lose its path to the internet. If you're stuck on that error, here is the immediate practical fix. We need to force our new network layout to take effect instantly using Ubuntu's modern network manager utility called Netplan. All you need to do is run sudo netplan apply. Once you run that, verify that your server can talk to the outside world by pinging Google. Ping -c4 google.com. If you see regular successful replies scrolling by, your internet route is fully restored. Now, you can confidently rerun your installation command sudo apt update and sudo apt install open-server -y. And hey, if you try this fix and you are still facing any issues, do not worry at all. Drop a comment right below this video with your exact error message, and I will personally jump in to help you fix it. Now, back to our server. Now that the package is installed, let's check the status again. Sudo systemtl status SSH. It shows a gorgeous green active, running status. Let's ensure this service starts up automatically every single time our server boots up by running sudo systemtl enable SSH now for the ultimate test. Let's go back to our Windows command prompt and try to SSH1 last time. Awesome! It's asking us to accept the security fingerprint key. Type yes, enter your password, and boom! The prompt changes directly to our secure Linux server prompt. We are officially in. We are managing our Linux infrastructure remotely from our host machine, the professional way. Now that we have professional remote access, let's audit the virtual hardware specs we built back in episode 1 to make sure everything is running smoothly. First, let's verify our exact operating system version. lsb_release-a perfect. We are running Ubuntu 26.04 LTS. Next, let's confirm our processing power. Run lscpu. Right here, you can see our allocated to CPUs, the specific model name, and the architecture layout. Now, let's audit our memory allocation. Free-H. The -H flag makes it human readable. We can see our RAM size is sitting comfortably at 2 GB along with a breakdown of our used and available memory. Finally, let's verify our storage layout. DF-H. This lists our total disk storage, showing our available space and where our system root is mounted. Look at how much incredible practical knowledge we tackled today, guys. We ran into missing packages, solved NAT versus bridged network deadlocks, deployed an enterprise open SSH server, and used Netplan to rebuild our live routing tables. This is exactly how real systems engineers learn, by breaking environments and fixing them live. In our next class, episode 3, we are going to dive straight into the Linux file system and basic survival commands so you can navigate this server like a seasoned professional. If you found this troubleshooting journey helpful, smash that subscribe button, drop a comment below if you faced any Netplan or VirtualBox hiccups, and let's keep learning the Linux way. See you in the next video. Take care, guys.